Hi everyone, welcome back for another episode in our saving and loading short series. If you haven't watched the first part, please go ahead and watch that first before joining this video. In the first part I cover a lot of the basics of saving and loading, and it's good to get understanding of those fundamentals before jumping into these more specific use case videos thereafter. So this one is all about saving and loading a world state, and what I mean by a world state is that you have a level and the player does something inside that level, such as open some doors, and then quits. You want them to save which doors were opened, and when they load up the game, talk about what doors are actually load up what doors are actually opened previously. So prior to starting, I made a door, quite a simple one-way door. Open it up, proximity, the door opens. If you want to know how to do doors, I've got loads of videos about how to do different types of doors. Just head on over and search in my channel. But you can see there, it doesn't close and it doesn't save its state. Okay, it just opens up as soon as I walk anywhere near it. So what I want it to do is save it in a save game object when the door descends. Okay, and I want to make it so I can easily store multiple doors inside that single level. So what I've got here is I need to first of all set up this door to have a variable to tell it to be open from start or not. So I'm going to open my door object here, and what you see here is basic door stuff. If you followed my tutorials, this should look quite familiar. We're going to add one thing to this, and it's going to be a Boolean variable. So click on the variables, and you want to call it isOpen. And you'll leave it as the red boolean. Okay. When this timeline finishes down this finished path here, I want to set isOpen to true. Okay. Click compile. And this variable is going to obviously change when it's actually opened, but it's also going to be checked at the start of the game whether this door should be opened or not. And what I'm going to do here is add a begin play event, which is going to check that variable. So if I drag that variable back out and choose get and put it into a branch, I can now go down to true and change the door mesh so it's opened. So here I'm just doing a basic translation in world space. So I moved it down here by -300. So what I'm just going to do is set that static mesh. Set relative location. Set that static mesh in the Z by -300. Okay, so I'm just basically telling it to go into the ground if isOpen is true. Click compile. Now if you had an animation or anything like that, it's a bit trickier because you want to tell it to run that animation and tell it to start from the last frame, so it runs it from the last frame and stays there. Okay, so that's how you do it with animation. I'll maybe do another video later on when I've got an animated door I could possibly show you. Anyway, so back to what the video is about. So here I've got basic isOpen being checked. If it's true, it changes the location of the door to be in the ground by default. Okay, so what I need to do now is store the state of this world in my save game object. Now, like in the first part, I made a player save data structure. I'm also going to make a level structure as well for each level I would have in my game. So in blueprints, I'm going to structure and go level. For base states of argument, I'm going to call it level 1 structure or save data. And in here I would have all the variables associated to my level 1. Okay, so the various types of doors I would have, I don't know, lights I've switched on, could be anything. Okay, so here I'm going to call this one doors, and in the doors I'm going to change this to a door actor, and I'm going to change the type here, the container type, from a single variable to a map. Okay, so I'll do a map video. I'll probably have a map video up by the time this video comes out, so head up and check out the map video and how maps work. But essentially it's like a two-dimensional array. We have a variable here, and then we have another variable associated to that. Okay, so this door being a reference to a particular door, and this is going to be a boolean to determine whether it's opened or not. Okay, and I'll click save and close that. So my level 1 save data is there. So my level 1 save data, I'm going to store and reference in my save game object first of all. So click on your save game object and add your level 1 data and level 1 save data as the structure. Okay, we can close this down. Okay, so with the save game object data in place, the level 1 data, the trick is now we have to be able to communicate with the save game data per level basis. Okay, so the only way we can really handle that is through the level blueprint, but there's a catch with that. We can't reference the level blueprint directly. So how do we get around that? Well, one way to communicate with the level blueprint is through a series of event dispatchers and using the game state. So the game state is something we have to create. So if you go to add new blueprint class, and in your search field you want to search for game state base and choose select, and we'll call this one my game state. And my game state is a game state is basically a client only level specific state of the game. Okay, so it's what replicates all the data across different clients if you're doing a multiplayer game, for example. But it's a handy way to store information about the level that we want to be able to access easily from various actors. So with my game state, once we made it, we need to actually tell the game to actually use it. So if you go to edit and project settings and click on maps and modes, and in maps and modes you'll see the selected game mode, there's a game state class, and here we can choose the my game state, and we can close that. So anything to do with the level changing and you want to store that change somehow, game state is a good place to put it. So with my game state, you want to open this up, and we want to first of all create an event dispatcher, and this is how we're going to communicate to the level blueprint. So this event dispatcher we're going to call door opened. So when we open the door, we're going to call this event dispatcher on the game state, and we're going to bind it to a function on the level blueprint. Sounds very confusing. It is kind of wibbly wobbly, but it's the best way of doing it, and the simplest way I could find anyway. So with a door open event dispatcher, we want to set a input for this. Okay, so with it selected on the right hand side in the details panel, you'll see inputs, and we want to choose an input, and we want to choose the actor. The door. Can't spell door that we're going to be opening. So choose object reference from that, and name this one door actor, like so. Click compile. We're going to close that, and on the door, once it's finished the timeline and we set is open to true, we want to get the game state, and we need to cast it to our specific game state, my game state, and as my game state we need to call door opened. And door opened, you can see that door actor input is required, and we just put in a reference to self. Okay, click compile, and now onto the level blueprint. So go to Blueprints up the top and choose Open Level Blueprint. And in here we need to set up that event dispatcher to call in here. So that door, when you open it, is sent to the game state to shout out that a door has been opened. Okay, and in here we're going to tell that a listening function or a listening event to listen out for that call being called. So on begin play, we're going to set up that listener. So we need to get the game state and cast it to our specific game state. And as my game state, we need to bind event to door opened. So when it's called, this event down here is bound to it. So here I'm going to create a custom event, and here is I'm going to call it door opened underscore. Actually, just leave door opened, it'd be fine. So door opened, the bound event is calling this custom event, and you see that door actor is now coming out of it. On the variables side of things, we can add our level 1 data. So level 1 data, and that is going to be a type of level 1 data. Save data and click compile. Apologies. So we want to go drag our level 1 data out, click the structure. We need to right click and split it to get our level 1 data doors, and then from there we want to choose add from the map options, and you can find those in the utilities. You can just type in add, but you will get a few various options. You want to make sure it's the utilities map add. Okay. And what the add does, it will add it to the map variable. However, if it does exist, it will just overwrite it. Okay. So here, door opened is triggered, and what we can do, because this is a specific door actor, we can get the is open value and plug it in like so. So now this is now storing data when we open a door. So let's go run through that series of events, what happens then. So let me just compile this and go through it. When we open a door, it runs a timeline, and when that timeline is finished, it will change this variable to true, get the game state, and call the door opened event. On the game state, we have a event dispatcher called door opened. That is what's being called by the door. On the level blueprint, we have set up our game state's door opened event dispatcher to be bound to this custom event on the level blueprint. So on this custom event, we are getting the level 1 data we've created over here. This is empty, not related to the saved data at all yet. Getting there, getting the map inside of that structure, and adding this door and its open status to it. Hopefully that makes sense. Okay, so that's the long and short of it. So this is going to now finally change this data, but we haven't actually saved it to the save game. So now we actually need to save our data to our save file. So on a level blueprint, we're going to create two functions. We're going to create the save level data and the load level data. And what we need to do here is, on the save anyway, let's do save first. We need to get the game instance and cast it to my game instance, and from there we can get the save game data. So that save game data has that variable on here too, so we need to basically copy this data over to our save game data. So here we're going to set level 1 data to match this. Okay, so that is now copying that variable data into the save game data slot here. After which we want to save game to slot. Which we can get from my game instance the slot name, like so. So when we save the level data, we get the game instance, cast into the game instance, get a specific one, and we're copying over our level 1 data, and then we're saving the game to slot, to the file. Now we go to load level data. So load level data works pretty much the same. We're going to get the game instance, cast to my game instance, and as my game instance we're going to get the save game object, get the save data. Ooh. And then from there we can get level 1 data and storing it in our variable on our level blueprint. So that is copying then the data from our save data file into our level blueprint. It hasn't actually used that data yet, it's just loaded it up. So on the event graph here we need to actually take when to save and when to load. So the saving's easy. On door opened, after we've done the add, we want to call the save level data. On the load level data though, we want to do that on the event begin play. So on begin play, at the end of the bind event, we want to drag on the load level data, and that will now populate the level 1 data variable with stuff from the save data file. With that stuff, we need to do something quite fancy. So the problem we would encounter is normally we would click on the door here, go into our blueprint, right click, and get a reference to that specific door. However, I want to make this a bit clever, so I would may have multiple doors in my level, and I don't want to do that process, this same process for every single door. So instead of doing that, we are going to get all actors of class and choose your door from the list, and then for each one of these in a for each loop, we are now going to get that level 1 data here that we've got from our save data. Remember, this is the save data we've done from the load here, and then from there we can split it and get the map and choose find. The array element now can plug into that find. So this find will search through that map for this particular instance of door, and that instance of door is out of that list of doors. So if I have 5 doors in there, it will go through all 5 of them and find the 5 doors in here. Now you've got 2 booleans here. The top one is our one that we've associated to the map. Okay, that's our one. And the bottom one's true or false, whether or not it finds it. Okay, so I want to do a boolean to here, the bottom one, because if it's false, I don't want it to do anything. Okay, I want it to only do something if it is true. Okay. So for each door it'll find in this level 1 data, I want to then set that door. So drag your array element out here and go set is open to true, and the top find boolean will go into the is open, and click compile. So that will now open all the doors that need to be opened. So let's test this out. Okay, so it didn't work because of one thing. The begin play of the level blueprint, we can't determine when that's going to occur in the whole list of other begin plays. They all just kind of fire. So what was happening is the level blueprint begin play was firing after the level the door blueprint's begin play was. So to counteract that, what we need to do is, once we've changed this value here, we need to tell the door to update its status, basically. So on the door asset, we need to add on the begin play here a custom event called update door. That's not let me. Hang on. Custom event update door. There we go. and that will plug into the same branch the begin play does. So basically you just run begin play again. Okay, so back onto our level blueprint. Once we've done the array element setting is open, we can drag out from there and go update door. So it will now update each door with the new value. Okay, alongside the update door, we need to add onto our open door value here to check whether or not it is actually open first before we run this timeline again. So drag the is open out, and we want to check it in a branch. If it is false, we want to if it is true, no, what do we do? If it's open, we want to open it. So false, we want to open the door. There we go. That's better. That's right. So the beauty of this is now I can add multiple doors to my map. So if I just put one over here and just raise it up, I don't have to do any extra code for this to work. So you can see the door is opened here. I can run straight through, and then this one will open. Once it's fully opened, it will save it, escape, push play, and you can see them now both open and close. Oh, sorry, both open. So this makes it really flexible, so you can add in many doors as much as you like. So if you want to do a second level, you just make a second level save data and add that to your save game object. So your save game object, you're saving data for each individual level separately. And then on the level data, on the level blueprint, sorry, this is where we want to handle that data and what we do with it. So you could have numerous things in it. It can be not just doors, it could be anything. It could be NPCs, whatever. So you want to keep that on the level blueprint because that is unique to the level itself and how it works. That's why we have to save and load level on the level blueprint rather than the game instance, because this data is specific to the level that we're running. Hopefully this makes sense to you. If you have any questions or you want to see more specific stuff in saving and loading, please let us know in the comments below. And thank you to everyone who's supporting me thus far in Patreon. Big help. Everything you do for me is great, and I can't wait to see where we go in the future with this channel. Thanks again, and I'll see you guys next time. Bye bye.